Welcome back, students. In this tutorial, we're going to talk all about filters, what they are, and how basic synthesis, in this case subtractive synthesis, uses filters to help us craft and carve a particular sound that we might be looking for. So let's look at filters. So we mentioned in our introduction that filters are one of the parts of synthesis that we use to remove or subtract certain things from our waveforms. In this case, what we're removing are frequencies. So we use filters to remove frequencies from our waveforms. And remember the waveforms that we've discussed so far: square wave, sawtooth wave, sine, triangle wave. To understand how filters carve or craft a sound in a synthesizer, let's talk about a basic analogy. Every car engine has an engine oil filter, okay? And what it does is it filters the oil each time it passes through the engine. Our engine oil filter can be viewed in two ways. We can look at it in terms of what types of things it will remove from the oil. So, for example, some small transmission or other types of metallic particles that it might filter out or remove, dirt, grunge, grime, that kind of thing. Or we could think of the engine filter in terms of what it is allowing to pass through the filter. In this case, it's going to allow clean oil to pass through the filter. So we can either look at it in terms of what it's filtering out or what's being allowed to pass through the filter. The same is true with filters that are used in synthesizer. We can look at them in terms of what they are filtering out or what is being allowed to pass through the filter. I mentioned that we're filtering out frequencies. Well, there's something else that we discussed that was very similar to that. In Module 2, in our basic audio signal path, we talked about EQing and the process of using EQ. It's an insert, and it allows us to remove or to add frequencies. Well, a filter sounds a lot like an EQ. Sounds like they have a lot of similar characteristics, and they do. One of the main differences between a filter and an EQ is that filters remove frequencies. EQs can add or subtract frequencies. So filters only remove or subtract frequencies. EQs can add and subtract frequencies. That's a basic way of differentiating between what a filter does and what EQ does. They both manipulate the frequencies, but filters, for the most part, just remove frequencies. They don't add them. In basic synthesizer architecture, there are three filter types that are the most common. The first is called a low-pass filter. The second, a high-pass filter. And the third, a bandpass filter. These all have abbreviations that are real common as well. LPF, HPF, and BPF. Now, the final filter type we're going to talk about is something called a notch filter. So what's the difference between these four types of filters? Just a few minutes ago, we discussed engine oil filters and how they can look at filtering oil in two different ways. One is what is allowed to pass through the filter, and the other is what is being filtered out. Same with these musical filters, or filters used in synthesis. These filters up here tell us they are allowing certain things to pass through the filter. This one, the notch filter, doesn't say that. So let's diagram a couple of these filters. In earlier discussions, Module 3, when we discussed digital audio, we talked a little bit about the range of human hearing. And you remember we said that humans can hear from 20 hertz to 20,000 hertz or 20 kilohertz. So if that's the case, we could diagram a filter. If this is our frequency response, 20 hertz or low frequencies up to the very high frequencies, 20 kilohertz, we could diagram this. And we could diagram a filter. So if this is our spread from low to high frequencies, and this is our ability to add or remove frequencies, then here's a question for you. What type of filter would that be? This filter is called a low-pass filter. The reason we know that is because what frequencies are being removed? Well, these frequencies here are being removed. And what frequencies are being allowed to pass through the filter? Well, these frequencies down here are being allowed to pass through the filter unaffected. So this is a low-pass filter. It's really common to look at this filter and go, oh, the high frequencies are being removed, therefore it's a high-pass filter. You just think of the same term, high frequencies, they're being affected, so it's a high-pass filter. That is incorrect. Remember, we have to think of it in terms of what's being allowed to pass through the filter. What's being allowed to pass, in this case, through the filter is the low frequencies. So it's a low-pass filter, or you could also call it a high cut, because the high frequencies are being cut, and the lows are being allowed to pass. So it's a low-pass filter. Okay, let's diagram another filter type for you. So here's our drawing. Now I'm going to draw a high-pass filter. So again, it's going to allow the high frequencies to pass, which means the low frequencies will be removed. So this would be a this would be a high-pass filter. High frequencies are allowed to pass. Low frequencies down here are being removed. So that is a description of a high-pass filter. The third filter type I want to talk about real briefly is a band pass filter. Now, a band pass filter is a little bit different. How it differs from the other two filter types is that a band pass filter allows a certain band of frequencies to pass through the filter. So this is our band of frequencies in here. Again, this is 20 hertz and 20,000 or 20 kilohertz. This is the band of frequencies being allowed to pass. All of this other data out here is going to be removed. So the only thing allowed to pass is this band of frequencies right in here. So this band can be either narrow or wide. So this could be band pass A, and this could be band pass B, and they are still very similar. They're both band passes, but the difference is the width of the band. Here, the A band is narrower than the B band. I like to think of this in terms of an actual rubber band. If we had a group of something grouped together like a group of sticks, okay? If we had a very small or narrow band, we couldn't get very many sticks inside of that rubber band. So that would be a narrow band, only allowing a few sticks or frequencies to pass through the band. Now, if we had a little wider band or a larger rubber band, we could allow more frequencies or sticks to be inside of that band. Okay, so we can have a bandpass filter that has a variety of widths in its band. This is called bandwidth. We also sometimes will call that Q or Q. It's the width of the band, the amount of frequencies in this case that are allowed to pass through the filter. Bandwidth, how wide is the band? Okay, so we can have, as an example, a bandpass filter that has a narrow band, and that band of filters, or that band of frequencies, could be like this. We could also have a bandpass filter that was like this, up here. So these are the frequencies that are allowed to pass, and they could be mainly high frequencies. The key is that it's only a band of frequencies being allowed to pass and everything else is being removed. Or we could have a bandpass filter that was in the lower register, or allowing only lower notes to pass and removing or deleting frequencies that are the very lowest and a little bit above that, all the way up to here perhaps. We can take and have a bandpass filter that is removing or allowing to pass mainly low frequencies, or allowing to pass mainly high frequencies, or somewhere in the middle. Okay, so we could have a bandpass filter that essentially kind of sounds like a low-pass filter or a high-pass filter or something in between, because it's just allowing a band of frequencies to pass through the filter. So that is the bandpass filter. The notch filter is a little bit different than the other filters that we've discussed so far. The others, low pass, high pass, and band pass filters, all tell us about the information or the frequencies that are being allowed to pass through them. The notch filter is a little bit different than that, in that it tells us about what is being removed from the frequencies. So it's kind of like that engine oil filter analogy I talked about. The other filters are allowing certain frequencies to pass, or good oil to pass through them. And the notch filter is like looking at it the other way. What is being removed from the oil? The notch filter might look like this. It's going to notch out an area of frequencies, and that is what's going to be removed. That information right there. Okay, so it's just the opposite of the other filters. It tells us which information is going to be removed, in this case, these frequencies, rather than what information is being allowed to pass. So this is a real common diagram for a notch filter. Now, could this notch filter also have a wide Q? Something like that? Sure. Or could a notch filter have a real narrow Q? Something like that. That's not the best drawing, but you get the idea. And the answer is yes. So the same things apply, bandwidth, Q, that type of thing, but the main difference is what are we removing rather than what are we allowing to pass. Okay, that's it for this brief discussion on filters. In the next tutorial, we're going to continue our discussion on filters and talk about frequency cutoff, resonance, filter slopes, and a few other things. So stay tuned.